Alright, I want to get straight on with this because I've not got much time. So, got this equation here, second order. All I'm going to do is write down the auxiliary equation. It will be m squared minus 4m plus 13 is going to be equal to 0. When you factorise that and solve that, you can do that on your calculator if you want to. I think it's 2 plus or minus 3i from memory. So we get complex solutions. So our general solution, no matter what, you would think would be y c1e to that bit, the 2 plus 3i, x plus c2e to the 2 minus 3i x. It's a very common thing, right? So then you can expand and compare your like terms like for like. You've got c1e to the 2x times by e to the 3i x plus c2 e to the 2x and then times e to the minus 3i x. You have to be careful where you put your c2s and all that funny stuff. Then I can factor in e to the 2x out of this at the front. So I get e to the 2x times by this, which is a whole mess. Right, it's absolutely horrible. It's c1e. Now, I've already got the x already, so I need 3x lots of I. So I want that plus c2e to the minus 3x times I. So you're going to get that out. Now, to expand that, we're going to need to use a little bit of our knowledge of e to the I theta is cosine theta plus I sine theta. So that's our exponential form of complex numbers. I've said let A be C1 plus C2. I'll get that out. Now, I also want to put B in there, which is going to be C1 minus C2 times I, where I is the square root of minus 1. If I add these two together, so if I did equation 1 plus equation 2, so I'm adding these together, I'm going to get A plus B over I. I know this looks silly, but it does work. It's going to be 2 times C1. And then I'm going to get A minus BI, bringing the power up, making it negative, it's going to be 2C1. You're going to get that out. Now, because we find that what C1 and C2 are using this, you're going to end up getting what you'd want, so we just want C1 on its own. So we're going to get 1/2 of A minus BI equal to C1. Great, we've got C1. So into equation 1, we're going to get A. It's going to be this, add 1/2 of that, so it's a half of A minus 1/2 B times I, where I square root of minus 1, and that's going to be equal to C2. Okay? So C2 is going to be that, where we've got 1/2 of A plus BI. That is the equation of C2. Now, going back to this, I'm going to sub these back into here. So I'm going to get e to the 2x times by, this is where you need your formula, you've got C1 cosine 3x. Now, if I remember correctly, we get plus C1 times sine, where I want the I going here. Now, the reason where your I goes there is because of that formula that I've just given you at the top of the page, right? So we're coming from that, plus C2 cosine of the minus bit, plus C2 I sine of minus 3x. Right? Alright, none of that. E to the 2x, multiply by C1 cosine 3x. This is where we've got a lot of cancelling that will be happening now. Now, what other C1s do I have? Well, I've got those, but I also want to keep the cosines together. I'm going to put the cosine 3x's together. Now, we're going to add C1 I sine of 3x. And then I'm going to minus C2 I sine. So we're going to get that out. That's not the end of the story, because then I can then factor out these C1s and C2s. So I'm going to get C1 plus C2, C1 at C2 times my cosine of 3x. And then to finish this off, I'm going to add C1 minus C2, which was these bits that we found over here, of I sine of 3x. So for completion, to finish this off, just before I forget, we've got e to the 2x. Now we're going to get times a cosine of the 3x plus the b times I sine of 3x. And that is the general solution to that differential equation. Done.